We know that there are three basic principles to programming, known as the programming constructs: sequencing, selection, and iteration. You've already had a look at sequencing, where one instruction is carried out straight after another in order. In today's lesson, we're going to look at selection, where you can get your algorithm to appear to be clever and make decisions based on the data that's input into it. So selection is just a decision or a question that's asked in the code, and then based on the answer to that question or based on the decision, certain bits of code will be executed and other bits of code will be skipped. We use selection every single day to help us make decisions. For example, if you're going out and it's raining, you'll decide to put on a coat. You've made a decision and you've selected to do something. If you're going to go and buy something from the shop, you make sure you've got the correct money. You've made a decision that you're going to do something, and then you've selected a course of action that allows you to do it. Think about this example of selection. You're at the theme park in the summer with all of your friends, and you're queuing to go onto one of the big roller coasters. As you go into the queue, there is a sign that says you've got to be 120 centimeters tall to ride the roller coaster. By the time you've got to the front of the queue, you've had to make a decision as to whether you can ride the roller coaster or not. Are you tall enough to be able to ride it? Is your height greater than or equal to 120 centimeters? If the answer to that question is yes, then you're able to go ahead and get on the roller coaster and ride it. If the answer to the question is no, sadly you have to leave the queue and go and choose another ride to go on. Here's another example from the theme park. You've joined the same queue for the same roller coaster, but this time you ask the question, have I got a fast track pass to jump to the front of the queue? If the answer to that question is yes, you're able to skip the queue and jump straight onto the next roller coaster ride. If the answer to the question is no, you have to stay in the queue and wait your turn like everyone else. Selection just allows you to make choices based on decisions. At some point, an algorithm that you're creating will need to ask a question because it's reached a step where one or more options are available. Depending on the answer given, the algorithm will follow certain steps in the code and ignore other steps in the code. Here's another example of an algorithm using selection. I've shown this algorithm as a flowchart to show the different steps that it will go through. The basic idea of this algorithm is it will ask you to input your age. It will then check your age to see if you're 70 years or older, and if you are older than 70, it will display something on the screen, otherwise it won't. If I was to input the age 70, it will check at the diamond to see whether the age is greater than or the same as 70. If it is, it will output on the screen, you are aged to perfection. If I input an age of 69, which is less than 70, when it gets to the decision, is the age greater than or the same as 70, the answer will be false, so it won't print anything on the screen and the algorithm will just stop. I've put an input into my algorithm, it's asked a question and made a decision based on that data, and then it's followed a certain set of steps based on that decision. In my age algorithm that we've just looked at, if your age was less than 70, nothing happened. There was no steps for the algorithm to follow. Let's change that a little bit. Here I've got a different version of the same algorithm as a flowchart. Again, it asks you to input your age, It then checks your age to see if you are the same as or greater than 70 years of age. If the answer to that question is true, it makes a decision to print on the screen, "You have aged to perfection." If you typed in 69 this time, rather than it doing nothing, it would check the question, "Is your age greater than or less than 70?" Decide that it's not true, it's false, and then it will print on the screen, "You are a spring chicken." Two different routes, two different sets of code that can be completed based on the decision that's made at that triangle point within my flowchart. Here's what my age algorithm would look like if I programmed it using Scratch on the left and Python on the right. So in the Scratch algorithm, I press the spacebar and it will ask me how old am I. It then creates a variable called age, and my answer that I've typed in, it will store in that variable. I've then got this if-else block that's used to make the decision, and it checks if the age is greater than 70 or the age is equal to 70, then say "You are aged to perfection." Else, say "You are a spring chicken." Let's take a look at how this would work using the Python code step by step. So the first part of my code is asking the question, age equals int, open bracket, input, open bracket, quote mark, how old are you, quote mark, and two close brackets. So this Python code, it will create the variable called age, and it will ask me on the screen, how old am I, and will wait for me to type in my age. The int part, remember, tells it to accept a whole number. So I can't put in that I'm 69.5 years. It would have to be 69. The next part of my code, if age is greater than or equals to 70, is the question that's going to be asked. It's saying if the value stored in my age variable is greater than or the same as 70, do the next bit of the code. The next part of the code, straight after the if line, is my true part. If the age that's stored in my age variable is greater than or equal to 70, it will perform these next bits of code. It will print on the screen, "You are aged to perfection." Note that the print command is indented a little bit. Python will normally put this indent in automatically for you. Don't be tempted to delete it out, because if you do, you will get an error message on your screen. The last part of my code is called the false part. Again, it's still checking if the number stored in my age variable is greater than or equal to 70. If the answer is true, it will do the first part. If the answer to that question is false, it will jump down to the else line and it will print out, "You are a spring chicken." It will do the false part of the code. Note on these two lines, the else doesn't have an indent and the print line does have an indent. Again, if you miss the indent out or keep one in where it's not needed, you'll get an error message when you run your code.